Yellowstone Volcano supereruption seems highly underestimated. We know that Yellowstone on the northwest corner of Wyoming is one of the world's 21 or so supervolcanoes. The last one that erupted was in the North Island of New Zealand. The Taupo volcano erupted about 26,500 years ago. And that was almost an extinction level event. Not only was it a volcanic winter, and these super eruptions can last for hundreds to thousands of years, let's keep that in mind. But the Taupo volcano super eruption did away with humans to the not only humans, fauna and flora, but anthropologists calculate there was only 2,000 couples left worldwide. Can you imagine how devastating such a super eruption could be for life? Now, scientists from US Geological Survey, who breezily informed the public that there's nothing to worry about with regards to Yellowstone caldera, a supervolcano that, should it erupt, it could cause potentially hundreds of thousands of deaths, should be eating their words now. We know that back in 2004, from one of my past videos, the US had an agreement for the relocation of Americans from that area to the southern hemisphere. And they paid billions of dollars for it. And it lasted for 10 years. I don't know what they did after that. Did they reactivate it as a relocation of Americans from the Yellowstone super eruption devastation? I don't know. Now, since about mid-July here, a couple of years ago, the earth beneath the volcano has been shifting in a sign that, of course, magma could be rushing into the caldera's main chamber. And we'll see some of the deformation on the caldera area. It is inflating, and it's going all over the place, breathing up and down. It's inflating, it's deflating. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below. And we know that Yellowstone, as a supervolcano, has 60% of the world's geysers and over 10,000 hydrothermal areas. It gives off 45,000 tons of carbon dioxide gas every single day. And this is the hot spot now. Since about mid-July of a couple of years ago, under the volcano, the magma has been shifting, giving signs that it could be rushing into the caldera's main chamber. And there have been since then roughly 2,500 small-scale earthquakes recorded near the volcano, and the largest stretch on record. Previous estimates had assumed that the process that led to the eruption took thousands of years to occur. The same estimates that USGS based on their warning. As New York Times explains, the Yellowstone caldera is the behemoth, far more powerful than your average volcano. It has the ability to expel more than 1,000 cubic kilometers of rock and ash all at once. That's 2,500 times more material than erupted from Mount St. Helens back in 1980. And that could blanket most of the United States in a thick layer of ash and even plunge the earth into a volcanic winter. And as the Times points out, scientists expect a supervolcano eruption to scar our planet once every 10,000 years. We're already overdue. The last one was 26,000 years ago from the Taupo volcano of the North Island of New Zealand. Now, to reach their conclusion, geologists, the team of scientists, spent weeks at Yellowstone's Lava Creek Tuff, a fossilized ash deposit from the volcano's last super eruption, and that's where they gathered samples and analyzed the volcanic leftovers. The analysis allowed the scientists to pin down changes in the lava flow before the last eruption. 640,000 years ago was the last super eruption. We've had a lava eruption 70,000 years ago, and another 80 eruptions since then. But now we're talking about a super eruption. Now, the analysis allowed the scientists to pin down changes in the lava flow before the last eruption. The crystalline structures of the rocks recorded changes in temperature, pressure, and water content beneath the volcano, just like tree rings do. Christy Till, geologist at Arizona State, and Ms. Shamlu, dissertation advisor said we expected that there might be processes happening over thousands of years preceding a supereruption. Instead, the outer rims of the crystals reveal a clear uptick in temperature and a change in composition that occurred on a rapid time scale. So it didn't take thousands of years, it took maybe hundreds of years. That could mean the supereruption transpired only decades after an injection of fresh magma beneath the volcano. So decades, not thousands of years. Thanks to this research, scientists are beginning to realize that the conditions that would lead to a supervolcanic eruption, a supereruption, could emerge during a human lifetime. As the research continues, scientists hope they'll be able to spot more signs of a coming supereruption. She said, it's one thing to think about this slow, gradual buildup, and it's another thing to think about how you would mobilize the mobile 1,000 cubic kilometers of magma in a decade, how that would move in 10 years. While scientists at the USGS brushed off the threat of a supervolcano eruption, we're talking about a supereruption, scientists at NASA have at least acknowledged the threat to the US population. The agency devised a potential strategy to try and diffuse and to mitigate by bringing down the heat of the magma to diffuse the eruption should one happen and appear imminent, though according to the several techniques involved, specifically pumping water directly into the volcano's magma chamber involves significant risks because you can bring about a supereruption by mistake, obviously. If you watch the video before this one, cooling off Yellowstone supervolcano, NASA playing with fire, that's what they had the plan to decrease the heat and mitigate the supereruption. Now, who knows? If the research is accurate, an eruption could emerge as a serious threat to the US and possibly the global population as the fallout, of course, does away with crops and livestock. It would be what we call a quote-unquote extinction level event, when very little of life is left, causing widespread famine, while clouds of choking ash and debris spread for hundreds, if not thousands of miles. And this is the new information that these scientists found that it couldn't happen. The supereruption and magma under the volcano could erupt in a lifetime, not in thousands of years. So this is by Tyler Durden, Zero Hedge on Bended Reality. Okay, here we are, Yellowstone Volcano Observatory, USGS. And this is the caldera. The white outline is the caldera, and this is the lake, Yellowstone Lake. That's Hebgen Lake. This is Yellowstone Lake. This is the border of a national park at the northwest corner of Wyoming. And you can see the various color bands here show you the various movement. It's basically all over the place. Color bands in the radar interferogram depict the pattern of surface deformation at the Yellowstone caldera, September 22nd, 2004 to August 23rd, 2006. So it's pretty old. Now the southwest, northwest, southwest, northwest parts of the caldera floor rose about 4.3 inches during that time and 5.9 inches respectively. So this was raising, going up faster. Yes, and respectively, while the North Caldera rim near Norris Geyser Basin subsided about 2.8 inches. So the way they do it is using, of course, INSAR and GPSs, a technique for mapping the ground deformation using radar images of the Earth's surface collected from orbiting satellites. Leveling preceding GPS and INSAR. Scientists use classic land survey techniques to map the surface deformation, leveling surveying technique used to measure vertical deformation, surface uplift, or subsidence. It's decidedly low-tech compared to GPS or INSAR, but it played a pivotal role in understanding Yellowstone. And if we go into the our monitoring, and we'll go to see some GPSs there, the monitoring map. Okay, let's take one that we saw before. That's a little bit too detailed. Let's go out a little bit so we could find this one. In the center, just about the north part of the caldera. And the GPS here. The displacement It's a diva. We have to do it twice. Okay. And there we go. So if it goes up, it means it's going east. And this is since 2006 to today. It was going west and then leveling up, and then west, and then it's going east since 2014. And it's going, it was going north, then south, then north, then south. So it's going southeast. And basically it was inflating, deflating, inflating, subsidence, and now it's inflating. So basically it's going all over the place. And let's take one to the south, right here. Okay, this one is going, this basically, again, it's going all over the place. Okay, it was going south, then north, and then south, then north, south, north. And this is going west. These ticks have to do with the seasonality of the water that's in the ground. And obviously this is pretty stable, seasonal, but it's also uplifting here. So I'll leave links below for you for this. Thank you for your support. Please leave your comments. Thank you. What we wanted to say here is that the recent conclusions from scientists, geologists, is that from the mineral examination, they found that it does not take thousands of years to come to a super eruption. It takes a lifetime. That's how short it could be. Please leave your comments. Thank you for your support.